Section 3.2, Part 1, Measures of Dispersion. Lesson objectives: compute the range of a variable from raw data, compute the variance of a variable from raw data, compute the standard deviation of a variable from raw data. To order fast food at McDonald's restaurant, one must choose from multiple lines, while at Wendy's restaurant, one enters a single line. The following data represents the wait time in minutes in each line for a simple random sample of 30 customers at each restaurant during rush hour. For each sample, answer the following. What was the mean wait time? Draw a histogram of each restaurant's wait time. Which restaurant's wait time appears more dispersed? Which line would you prefer to wait in, and why? Here's our raw data. We have the wait time at Wendy's and the wait time at McDonald's. If we were to compute the mean time, we can compare. So the mean wait time for both turned out to be 1.39 minutes. Just based upon the center, these two are identical. However, if we look at the histogram, we can see the histogram for Wendy's is different than the histogram for McDonald's. If we have a data set, we need to talk about the center, the representative value, but we also need to talk about the spread, the variation. So which restaurant has more variation? Well, we'll come back to this and we'll answer this question by using what's called the standard deviation. Data sets can have the same mean, median, and mode, but yet they can be different. Team 1 and Team 2 have both the same mean, the same median, and the same mode. There's difference among the spread. Group 2 has the shortest person and at the same time has the largest person. There's more spread. Group 1 is what we would say is more consistent. Everybody is close to the same height. Lesson objective number 1, computing the range. The range, which is denoted by a capital R, is the difference between the largest and the smallest. That's the strength of the range. It's very easy to compute. The weakness of the range, however, is only looking at two values. It only looks at the largest and the smallest, and none of the values in between have an effect on the range. For this example, Team 1, the range is 6 inches. For Team 2, it's larger, it's 17. Lesson objective number 2, compute the variance. The population variance of a variable is the sum of the square deviations about the mean divided by the number of observations in the population, n. That is, it is the mean of the sum of the square deviations about the population mean. Now, deviation, just the easiest way to think about it, is how far a value is away from the mean. So the variance is simply the average of the square deviations. How far are they away from the mean? The question maybe becomes, why do you square them? Well, we'll get to that. Now, the population variance is represented by lowercase sigma squared, and this is the symbol. Here's the formula. Again, this means sum, so you take each value, subtract the mean, you square it, add them all up, and then divide by how many you have. So it is the square deviations about the mean. The sample variance is computed by determining the sum of the square deviations about the sample mean, that's x bar, and then dividing this result by n minus 1. So here's the formula for the sample variance. This is what we'll be using in this class. So you take each value, you subtract the x bar, the mean, and then you square it, and then you add all those up and divide by n minus 1. Why do you divide by n minus 1? Well, whenever a statistic consistently overestimates or underestimates a parameter, it's called bias. To obtain an unbiased estimate of the population variance, we divide the sum of the square deviations about the mean by n minus 1. So in other words, we lose what's called a degree of freedom. So if we have 10 observations, really we have 9 degrees of freedom, so we divide by 9. Okay, let's look at an example and see if we can see what this formula is trying to tell us. So we have 3 points from a sample, 3, 4, and 8. We want to compute the sample variance for this sample. Unlike the range, which only uses the highest and lowest, let's have a reference point and let's see how every single value deviates away. Okay, now what's going to be our reference point? Well, if you think about it, the mean is a good reference point because it's the center of gravity. So if we look at how each point, the distance from each point is away from the mean, then we can talk about the spread of each point away from the mean. So that way, every single point is important. So the first thing we want to do is take 3, 4, and 8 and compute the mean, which turns out to be 5. So here's our reference point, 5. How far is is 3 away from 5. So if we take 3 minus 5, we end up with a negative 2. So this is minus 2 deviations away from the mean. We take our next value, 0.4. 4 minus 5 is negative 1. So this is a negative 1 deviation away from the mean. And then we take our last data point, 8, we subtract 5, and we see that this is 3, a positive 3 deviations away from the mean. So we have 3 different values. The next thing we want to do is find the average of those deviations away from the mean. But when we take negative 2 plus negative 1 plus 3 and we add them up, we will always get 0. And the reason for that is the mean is the balance point. So any data set, if you look at how far each deviation is away from the mean and you add all those deviations up, it will always be 0. So the easiest way to get around this is to take each of those values and square them. The negative numbers will become positive and the positive numbers will stay positive. So if we take 3 minus our mean 5, we get negative 2. 4 minus 5 is negative 1. 8 minus 5 is 3. So if we square each of these deviations, negative 2 squared becomes 4, negative 1 squared becomes 1, and 3 squared becomes 9. Now these are all positive numbers. If we add these up, the sum of the square deviations is 14. Now if we do our average and we take this sum and divide by how many we have, but because this is a sample, we want to divide it by n minus 1, which would be 3 minus 1, which is 2. 14 divided by 2 is 7. So the variance for this data set is 7, and we denote this by using s squared. Now, how do we use technology to compute the sample variance? Well, we'll start with Minitab, and then I'll show you in StatCrunch. The data that we're using is the student survey data from the early fall 2009. On Minitab, we first go to Stat, Basic Statistics, and then Display Descriptive Statistics. We want to select the variable, age, and then we want to select the Statistics button. We want to select Variance, and then hit OK. In the session window, we see that the variance is 64.098. The units for the variance are squared, and we had to square because otherwise if we sum up the deviations, that's always going to be equal to 0. Really, there's not much practical interpretation that we can derive from sample variance, and the standard deviation will eliminate this unit problem. How do we compute the sample variance in StatCrunch? Well, we go to Stat, Summary Stats, and then we choose Columns. We select the variable, age, and then we see that the variance is right here. Okay, lesson objective number 3, compute the standard deviation. The population standard deviation is denoted by sigma, and it's obtained by taking the square root of the population variance. So sigma is equal to the square root of the variance, sigma squared. The sample standard deviation is denoted by s, and it's obtained by taking the square root of the sample variance, so that s equals the square root of the sample variance, which is s squared. Now the reason why we're taking the square root is to get back to the original units. Here's the formulas. Again, this is a parameter. This is measuring something by the population. In this class, this is the one that we're going to use. We're going to use the sample standard deviation, which is denoted by S, and this is a statistic. If you remember our problem from variance, S squared was 7. So we want to compute the standard deviation of this. So if we know the variance is 7, all we have to do is take the square root of the sample variance and we get the standard deviation. Square root of 7, which is approximately 2.65. So what this means is that data set 3, 4, and 8, the average deviation away from the mean is about 2.65 units away. To compute the standard deviation in Minitab, we go to Stat, Basic Statistics, Display Descriptive Statistics. We choose our variable, and in the session window, this STDEV is short for standard deviation. In this example, the average deviation away from the mean age is a little more than 8 years. In StatCrunch, we go to Stat, Summary Stats, choose Columns, select our variable, and it is displayed right here next to the variance. Okay, let's go back to our McDonald's and Wendy's example, which is larger in Y. If we were to take this data set here from this sample and the one in this sample and compute the standard deviations of both, you would see that the standard deviation for Wendy's is 0.738 minutes and the standard deviation for McDonald's is 1.265. So there's more variation in the McDonald's waiting time than Wendy's. Wendy's is more consistent. Thanks for watching Section 3.2 Part 1.